Yes. Good morning, my dear students. Yes, today we are going to discuss the topic construction and working principle of a DC generator. Yes, from the name itself, we can identify that I am going to explain the constructional parts and the principle of a DC generator. First, let me explain the generator principle, then we will go into the topic construction. Because before going to explain the constructional parts, we must know what are all the essential parts required in a machine to generate electricity. Okay, now if you want to generate electricity, we must have some essential parts. So the parts which are, we must have a conductors, then the conductors, it is nothing but it can be made by means of copper or aluminium. So based upon the type of machine, based upon the size of the machine, it will vary. So conductor, it is nothing but a group of coils. Then the another thing which we required is magnetic field. Conductor, magnetic field, then relative motion, between this conductor and magnetic field. So the relative motion, it is between this conductor and magnetic field. So these are all the three main essential parts in any machine which is generating electricity. Now, how I can say that these are all the three essential parts of a machine, of a generator? So for that, first we must know how we can generate electricity by means of any machine. So now I will come to the law. We know that a Faraday's law of electromagnetic induction. So Faraday is a scientist who invented how to generate electricity. So now I am going to say the law 1. By means of Faraday's law, the law 1, it states when a conductor, it is nothing but a conducting material, it is linked with the magnetic field. When a conductor, it is linked with the magnetic field, an EMF or an voltage, it is induced in that conductor. So that is a law he stated. So by means of this law only we are manufacturing, we are following all the, we are manufacturing all the machines. Either it is a motor, it is a generator. The concept behind that is this law only. So as I said, whenever a conductor moves in a magnetic field, or we can say whenever a conductor links in a magnetic field, a voltage or EMF is induced in that conductor. So now we come to this point. So we need in that law, we need some conductors, because we are going to move the conductor in a magnetic field. So for that we must have conductor. Then magnetic field is another essential part. Then what is this? Relative motion. So what that law says, we have to move the conductor in the magnetic field. So the relative motion, it will do that operation. That means by moving the conductor in the magnetic field, so an EMF will be induced in that conductor. Now I am, with the help of some small diagram, I am going to explain how electricity can be generated. Now let us assume, so this is permanent magnet. This is north pole, this is south pole. Then this is a free space. Let us assume this is a free space. We know that the magnetic field which will flow from north pole to south pole. That means the magnetic flux, it is flowing. Now I am going to place a conductor. So I have shown a red color conductor at this area. It is red in color. Then this is another conductor. It is blue in color. Now what Faraday's law says? We have to move the conductor. To make the conductor has to cut the magnetic field, so that we get the induced EMF. So for that we have to give a mechanical input. a mechanical input we have to give, because to do the relative motion between this conductor and magnetic field. So now I am moving the conductor which is moving like this. Now initially it is like this, then if it is moving like this, so this part it will go at this direction, this part it will go this direction, so it will keep on, it is moving. Now by means of, because you have to give mechanical input, if you have given this conductor, it is rotating like this. Now it is in this position. If you are rotating means it will rotate like this. Now red color conductor will come to here, blue color conductor will come to here. This operation is continuously it is happening. Now we can get electricity, but we have to many constraints are there. So dynamically here the EMF induced in this machine, it is dynamically induced EMF. This is nothing but dynamically induced EMF. What is that dynamically induced EMF? Now we can ask, so is there any other related induced EMF? Yes, we have two induced EMF. It is, one is statically induced EMF and dynamically induced EMF. Statically induced EMF, it is a EMF which is induced in static machine. The only static electric machine, it is a transformer. So the voltage induced in a transformer, it is statically induced EMF, that is different. The voltage which is induced any rotating machine which produces electricity, so that is dynamically induced EMF. So dynamically induced EMF, so we know that induced EMF E, which is equal to B L V sin theta, where B is the magnetic flux density, B, then L, length of the conductor, how much length of conductor we have used, so that influence your voltage. So length of the conductor, now what may be V? V is not a voltage, it is a velocity, because we have given mechanical input. At what much level, at what extent you are giving mechanical input, with some velocity you are going to give some mechanical input, say some 1000 rpm or 1500 rpm, so that velocity. So that velocity which will also determine your voltage. So the velocity, but here in that case we have used to represent, it is meter per second. Now, so this is B, magnetic flux density, this is length of the conductor, this is velocity. So magnetic field density means flux per unit area, magnetic flux per unit area. So these are all the three things which are essential while calculating your induced EMF by generator. So now what is meant by this theta? This theta, it is nothing but it is an angle difference between plane of magnetic flux and plane of the conductor. The theta is nothing but it is a angle difference between plane of conductor and plane of magnetic flux. So now, so this theta which is going to determine your voltage level. For example, this theta value is equal to 0, na? Sin 0 equal to 0, you won't get any voltage. If this theta value is equal to 90 degree, sin 91, so we will get maximum voltage. So this theta value which is going to vary. Now, what is the plane of conductor and plane of magnetic flux? That means axis. So this is your plane of magnetic flux. This is dotted line which shows your plane of magnetic flux. Then this conductor plane is like this. So when the plane of conductor and your magnetic flux, it is like this. So that means 90 degree. You will get maximum voltage. If your plane of conductor and plane of magnetic flux which are same, which are in phase, there won't be any degree means you won't get any voltage. So that is very important. So if you are keeping your conductor and magnetic flux, it is like this. At that time you won't get any EMF. You must keep your conductor, you must move your conductor with like this. So the conductor, this is your magnetic flux axis, this is your conductor axis. We must have your conductor and magnetic flux like this. At that time only you will get maximum EMF. Now you cannot keep this angle at a constant value, because we are keep on varying this value. Because the angle which are keep on varying. So when at a particular portion, this angle at this portion, the angle which this is the plane of conductor axis, this is your magnetic flux axis. Now it is 90 degree. Now after a particular time, your red color conductor will come to this portion. Your blue color conductor which will come to this portion. At this time, plane of angle and magnetic flux value is 0 degree. So it is varying. So your induced EMF, which depends upon your magnetic flux density, then your length of the conductor, then velocity of motion, then theta, sin theta. Sin theta is nothing but the angle theta is the angle difference between your plane of conductor and plane of magnetic flux. Now we are going to see how whether this induced EMF it is DC or AC. Yes, in any machine, in any electrical machine, the generated output it is AC only. Why? Because see, if a conductor it is lying at this position. Now the conductor it is lying at this position means the conductor it is occupied at north pole. At that time the current direction in one direction. Then when the conductor it is occupied in at this position, that is south pole, then the current direction which will differ. So if you are given a mechanical input, so alternatingly you will get when the conductor when it reaches north pole, the current direction is different. Then when the same conductor which reaches to south pole, the current direction is different. So you will get an alternating current in any machine. The generated output in any machine it is a alternating current. So now this is your DC generator. Is it? Have you understood? So the generated output it is a DC, AC. Because when the conductor which occupies near to the north pole, the current direction is one direction. Let us assume at this pole. At this motion means it is north pole. Then the same conductor it is lying at this portion. Your current direction it is negative. So that means that conductor it occupies south pole. So now I want to convert this AC into DC. So for that purpose, a separate apparatus we have to use in a DC machine called commutator. So commutator it is a part which is going to be used in a machine, in a DC machine, to convert generated alternating current into direct current. So that we are going to see practically while discuss about constructional parts. So now we are going to see the practical assembly of a DC generator. We have discussed DC generator working principle. Now we are going to see how practically they made DC generator. So this is your demo motor which is available in our electrical machines laboratory. So as I said, we need three essential parts to generate electricity. So magnetic flux or magnetic field, conductor, relative motion. Now this moving part, it is your armature. So this armature it contains more amount of coil, that means conductor. So conductor it is available here. This is your armature part. It consists of conductors. So that is over. Now conductor part it is there. Now we need magnetic flux, is it? So magnetic flux in a principle of operation I explained with the permanent magnet. So in any electrical machines, the electric machines is made with of electromagnet. So this part it is a part to produce magnetic flux. Let us assume. So this is a coil. This is a core assembled. This part it is your core assembled. This is your coil. So this setup which will produce magnetic field. This setup which will produce magnetic field. That means this is a conductor. This is your conductor. This is your core. So whenever supply is given to the supply means voltage is given to this coil, a magnetic flux will be produced. So this part, it is an electromagnet to produce magnetic field. So now magnetic field also is there. Now we need to give mechanical input. That means we need to give a relative motion between conductor and magnetic flux. So for that we have given a shaft. So if you are moving this shaft, what is happening? A relative motion it is there. The conductor is moving with respect to magnetic field, is it? So here. So now if you are given mechanical input, so mechanical input by means of hand I am giving some rotation. So mechanical input, I can get electricity. I can get electrical output. So I am rotating here. So by rotating this, I can get electricity. That's all. Now, while explaining the principle of operation, I said a DC generator, we have a part to convert generated AC into DC. So for that, we must have some commutator assembled. So this part, see here this part, it is fixed with the armature, the commutator. This part, it is a commutator. It is a part which generates, which converts a produced alternating current into direct current. So that's all. Now with the help of brush assemble, we are collecting that current. So here the carbon brush is there. This is your carbon brushes. So by means of this brush, we are collecting the current from the armature circuit. We are supplying to the load which you have connected to the generator. So by this is what we assemble. This is what your constructional parts of your DC generator. Thank you.